Welcome to Trig Unit number 4, Law of Sines and Cosines. What we're going to be doing today is working with triangles that are not right triangles. So Pythagorean theorem doesn't work anymore, and regular sine, cosine, and tangent don't work anymore. Those only work with right triangles. So instead you have to use these formulas we've got right here. Now, law of sines can be used if you know two sides and a non-included angle. That means the angle that's not in between them. For example, I know two sides on this first one, and this 115 is not in between the 11 and the 20. Or if you have any two angles in a side, then you can use law of sines as well. Here's how law of sines works. Imagine you have a triangle. We're just going to draw like a general triangle, not a right triangle, and we're going to mark the points vertex A, B, and C. Vertices, there we go. And then the sides across from them are going to be labeled the same way but with lowercase. So across from angle A is going to be side A. Across from angle B is going to be side B. And across from angle C is going to be side C. So basically you're going to divide the side by sine of the angle, and that equals another side divided by the sine of its angle that's across from it. And you're going to use two out of these three fractions, whichever two you have at least one piece of information for. So on this first one, for example, if I know this 115, I can put sine of 115 on the bottom. And on the top, I'm going to put 20. And then on the other side, I've got the 11. It's the side, so it goes on top. And sine of the angle goes on bottom. But I don't know that angle. It's angle B. There I have it. Now, to solve an equation that has two fractions equal, you're going to cross multiply. That's going to be 20 sine B equals 11 sine 115. Now, to get B by itself, you divide by 20. And that means that sine B equals 11 sine 115 divided by 20. 0.49. Yes, I know that would round to 0.50. I'm just writing it down to keep track of it for right now, because I still have one step left before I have this, so I'm not rounding till the end. Now, how do I get rid of a sign? I can't divide by it. I have to do sine inverse. And I'm just going to draw an up arrow because I'm not actually going to type 0.49. I'm going to hit second sign and then go to the up arrow and enter that whole decimal in. So it turns out that B is about 29.90 degrees. Now I'm going to hang on just a second for side C, because I don't have enough information. If I don't know side C or angle C, I'm stuck because I don't have any pieces of that fraction. So in order to get angle C, because I know that this is a triangle and B is 29.9, I would do angle C is 180 minus 115 minus 29.9, which is 35.1. So now that angle is 35.1. Now I had to know that because I can keep this same fraction from up there. 20 over sine 115 equals. But instead of using B, I need to find C. So I'm going to put side C over the sine of 35.1. And then I cross multiply 20 sine 35.1 equals c times the sine of 115. And then I divide by the sine of 115 to get c by itself. This time, c is not part of the sine function, so you don't have to use an inverse to solve for it. I just have to do 20 sine 35.1, close that parentheses, divided by sine 115. 12.69. Let's try another law of sines. I'm going to zoom out a little bit. On the second problem, I have 3 sides. I don't have any angles, so that's not enough for law of sines. On the third problem, bottom left, the angle is included between the 2 sides, so that's also not law of sines. On the fourth one, I have 2 angles and a side. Any 2 angles and a side means law of sines, because I can do the 180 rule to find this third angle. So if you have 2 angles, you pretty much have all 3. So I'm just going to do 180 minus 25 minus 107, and that is, oops, how did I get there? 180 minus 25 minus 107, 48. So boom, I already found that angle B is 48 degrees. And now I can set up the whole fraction for B. That'll be 15, because that's across from the 48, over sine 48. That's what you have to start law of sines. If you don't have one full complete fraction with the angle on the side, you're stuck. You have nowhere to go because you have too many unknowns. And then on the other side you pick, I'm going to start with A, and across from A is 25. And then I'm actually going to scooch this over a little bit and set up both to kind of show you the other setup, and then I'll work on solving both. So if I wanted to find C, I would start with the same fraction, and then C would be C over sine 107. So take a look at those 2 differences. It's just that one angle that changed. So solving it is still going to be fairly similar. I'm going to multiply these 2 and multiply these 2. Now that's going to be A times the sine of 48 equals 15 times the sine of 25. Since I'm not looking for an angle, I'm not going to have to use an inverse trig function. I'm just going to divide this and be done. You only have to use inverse trig if you're looking for an angle. So it's actually pretty easy to tell if you need one before you get started. 25 divided by sine 48. 8.53. Now if I focus over here on the one I set up for angle C, I have C times the sine of 48, just like I had A times the sine of 48 on the other one. But this time, instead of 15 sine 25, it's 15 sine 107. Just like the other one, to get rid of that sine 48, you divide by it. Very similar solving methods. 15 sine 107 divided by sine 48. 19.30.